Ninth question is the angular resolution of a 10 centimeter diameter telescope at a wavelength of 5000 angstrom is of the order of. Options are 10 raised to power 6 radians, 10 raised to power minus 2 radian, 10 raised to power minus 4 radian, and 10 raised to power minus 6 radian. We know that angular resolution delta theta is equal to 1.22 lambda by A, where lambda is the wavelength of light and A is the diameter of the lens. So it will be equal to 1.22 into wavelength is 5000 angstrom, so we can write it is 5000 into 10 to the power minus 10 meter divided by diameter of the lens, which is given 10 centimeter, so it will be 10 into 10 to the power minus 2 meter. On simplifying, we will have 6.1 into 10 to the power minus 6 radian, which is approximately equal to 10 to the power minus 6 radian. So option D is the correct option. 10th question is an astronomical telescope has a large aperture. Two options are reduce spherical aberration. Option B is have high resolution. Option C is increases span of observation. And option D is have the low dispersion. And the option B is the correct option because angular separation delta theta is 1.22 lambda by A, where lambda is the wavelength and A is the diameter of the lens. So resolving power of the lens will be 1 by delta theta, that is equal to A by 1.22 lambda. So we can say that the astronomical telescope has large aperture to have the high resolution because resolving power is proportional to the diameter of the lens. 11th question is wavelength of a light used in an optical instrument are lambda 1 equal to 4000 angstrom and lambda 2 equal to 5000 angstrom. Then ratio of their respective resolving power corresponding to the wavelength lambda 1 and lambda 2 is. We know that resolving power is equal to A by 1.22 lambda. This implies that for same length of the diameter A, resolving power is proportional to 1 by lambda. Hence, resolving power for wavelength lambda 1 and resolving power for wavelength lambda 2 have the ratio equal to lambda 2 by lambda 1. Lambda 2 is 5000 and lambda 1 is 4000 angstrom. So it will be simply 5 by 4. Hence option D is the correct option. 12th question is the diameter of the objective lens is A, its magnifying power is M, and the wavelength of the light is lambda. The resolving power of the telescope is. Options are 1.22 lambda by A, 1.22 A by lambda, lambda M by 1.22 A, and option D is A by 1.22 lambda. We know that resolving power is the inverse of the angular separation and it is given by A by 1.22 lambda. So option D is the correct option. Question number 13 is calculate the limit of resolution of a telescope objective having a diameter of 200 centimeter if it has to detect the light of wavelength 500 nanometer coming from a star. Options are 610 into 10 to the power minus 9 radian. Option B is 305 into 10 to the power minus 9 radian. Option C is 457.5 into 10 to the power minus 9 radian. And option D is 152.5 into 10 to the power minus 9 radian. We know that limit of resolution is delta theta, that is the minimum angular separation that the telescope can detect is equal to 1.22 into lambda by A. Lambda is the wavelength of light and A is the diameter of the lens. So it is 1.22 into wavelength is 500 nanometer, so it will be 500 into 10 to the power minus 9 meter. And the diameter of the lens is given 200 centimeters, so in meter it is 2. By cancelling by 2, 1.22 will become 0.61. So we have 0.61 into 500 into 10 to the power minus 9. And this 0, double 0 means 100. We will have 61 into 5 into 10 to the power minus 9. On multiplying, we will have 305 into 10 to the power minus 9 radian. This is the option B. A telescope has an objective lens of 10 centimeter diameter and is situated at a distance of 1 kilometer from the two objects. The minimum distance between these two objects, which can be resolved by the telescope when the mean wavelength of the light is 5000 angstrom, is of the order of, and options are 0.5 meter, 5 meter, 5 millimeter, and 5 centimeter. As per question, suppose there are the two objects, say O1 and O2. These two objects are having the separation x, and at a distance, say d, there is an objective lens. This objective lens of the telescope has resolving power equal to A by 1.22 lambda. So angular separation delta theta will be equal to 1 by resolving power, that is equal to 1.22 lambda by A, where lambda is the wavelength of light and A is the diameter of the lens. In the question it is given that delta theta is equal to 1.22. Wavelength of the light is given 5000 angstrom, so it is 5000 into 10 power minus 10 meter. And the diameter of the lens is given 10 centimeters. So in meter we can write it as 0.1 meter. So in simplifying we will have 1.22 into 5 into 10 raised to the power minus 10 into 10 raised to the power 4. So it will be, on multiplying, we will have 6.1 into 10 power minus 6 radian. And angle is arc by radius. And this arc by radius is equal to, arc is the separation between the object, that is x, and the radius, that means distance, is capital D. So we can write that x by capital D is equal to 6.1 into 10 power minus 6, and capital D, that is the distance of the objects from the lens, is given, which is 1 kilometer. So x will be equal to 1000 meter multiplied by 6.1 into 10 power minus 6, that is equal to 6.1 into 10 raised to the power minus 3 meter. So it can be written as 1.61 millimeter. And 1.61 millimeter is approximately of the order of, as per options, it is 5 millimeter. Hence option C is the correct option.